Okay, so I apologize. I made a mistake on the very first problem that we did in class, the first part of the first problem that we did in class, or I guess maybe the second part. But anyway, we have a sphere, or a hemisphere, x squared plus y squared plus z squared is equal to 16, and y is greater than or equal to 0. We were assigned to do the surface integral of a curl field over this hemisphere, and the first way that we did it was we did it as a line integral around the boundary of this hemisphere. Now, if I look in my standard x, y, z coordinates, this is x, positive x-axis. That's important. That has to do with the error that I made. This is the positive y-axis. This is the positive z-axis. Okay, the hemisphere is going to be the part of the sphere that's over here in the positive y-axis. Now, the curve that I drew in class was in the xz plane, okay, with the positive y-axis coming out of the origin, or coming out of the board like this. Now, if we think about how I can go from here to here, here the x-axis is coming out of the board, the y-axis is in the board this way, and the z-axis, the positive z-axis, is going up. So what I'm going to do is I'm going to kind of take this, the x-axis is sticking this way, the y-axis is sticking this way, and I'm going to take this axis and rotate it, so now the x-axis is going this way. So this is the x-axis, but over here is the positive x-axis. So it's oriented backwards from how we normally have it. This is the positive x-axis. This is the positive z-axis. This is still the boundary circle. It's a circle of radius 4 in the y equals 0 plane. This is still the correct orientation, but the parameterization is actually going to be minus cosine theta 0 sine theta, because we're going to start here and move in the counterclockwise rotation. If I had done cosine, what I had before was cosine theta 0 sine theta. That's going to start over. Here and move in the wrong direction. It's going to move in the clockwise direction rather than the counterclockwise direction. So this should be the correct parameterization. The reason that this was brought up to me is because the answer that I got would have been minus 16 pi this way, but the answer I got by computing the surface integral over this surface was 16 pi. That minus sign takes care of everything. So that was it. I apologize for screwing that part up for you. I hope this video helps somewhat. If not, talk to me about it in office hours, send me an email, something like that.